Hello, and welcome to today's E360 webinar titled Applying R-290 in Commercial Refrigeration Applications, brought to you by Emerson. My name is Kate Henderson, and I will be your moderator for today. We have just a few announcements before we begin. Please note that this presentation's audio is provided by phone or through your computer sound system. In addition, you may type questions that you have into the text area and hit send in the Q&A panel throughout the webinar. We will answer questions at the end and send out answers to questions that we may not get to in the coming days. If you'd like to revisit key sections of today's webinar, it will be available on demand at e360hub.emerson.com/webinars a few days after this live event. You'll also receive an email in the next few days with a link to the recorded event. Discussing today's topics is Katrina Kreitz, Director, Strategic Marketing, and Justin Miles, Account Executive for the Cold Chain. In her role as Emerson's Director of Strategic Marketing for Cold Chain, Katrina takes a holistic approach to helping customers solve problems. Her responsibilities encompass the strategic marketing of Emerson's major market segments of cold chain, including food retail, food service, and healthcare. These include, but are not limited to, setting and implementing growth strategies, understanding market trends and dynamics in order to prioritize key initiatives within product development, and implementing go-to-market strategies. Katrina has 7 years of industry experience. Previously, she worked 4 years in the AC side of the business in variable speed and other modulation product management, including compression, controls, and drives. In addition, she has 20 years of business-to-business marketing experience, including product and market management, marketing communications, and e-commerce. Katrina earned a bachelor's degree in business, human services from Urbana University, and an MBA in leadership, innovation, and change from Wright State University. Justin began his career with Emerson as an engineering co-op on the integrated solutions team, where he assisted customers in the design and integration of refrigeration condensing units. He was hired full-time after graduating with a bachelor's degree and quickly became the department's lead engineer in condensing unit design and manufacturing. 4 years later, Justin became an application engineer, where he was responsible for supporting multiple OEM customers in the selection, application, and qualification of refrigeration compressors, condensing units, and electronics. In 2018, Justin's passion to exceed customer expectations led him to join the cold chain OEM sales team, where he supports multiple strategic OEM partners. Justin earned a bachelor's degree in mechanical engineering from Wright State University. I will now hand it off to Katrina and Justin.
Thanks, Kate. So today it's wrapping up our series over the summer that we've started on low GWP pathways to low GWP solutions. So this is our last webinar in this series, and today we're going to talk about R-290. So I'll kick it off by talking about some of the trends that are driving R-290 adoption and what segments of business we see this fitting in. And then we'll get into regulations and standards, increasing those charge limits and what needs to happen in order to get those charge limits increased for commercial refrigeration. Justin will then talk about some of the thermodynamic properties of R-290 along with various performance characteristics. And he will then get into some of the safety considerations and best practices to make sure that our technicians out there are handling those refrigerants as safely as possible. And then, as Kate indicated, we'll wrap it up with questions. And so with that, let's get started. So some of the trends driving adoption of R-290. Across our industry, there has been a push through regulation activity between California Air Resource Board and America Innovation and Manufacturing Act. All of these regulations are driving towards a more sustainable future for our world in general. But on top of that, specifically in our industry, we're looking at lower GWP solutions, lower global warming potential solutions, and R-290 is one of those. If we look at it compared to some of the other refrigerant options out there, it is a regulatory meets regulatory compliance. It has a GWP, global warming potential, of 3. And you can, right now, the max charge applicable in North America is in US is 150 grams. We're driving towards 300 and 500 grams, depending on if it's open or closed door. And it's available today. It's a widely available refrigerant. So where does it fit, or where do we see it fitting most in the industry? So between food retail, we can see R-290 fitting in retail establishments where you have maybe a micro-distributed, you're increasing potential charge as on a micro-distributed system. That particular system is a little bit less adoption within the food retail segment. But really, when it comes to food service, this is an ideal refrigerant candidate. It has great merchandising flexibility because it's typically in a self-contained system. The first cost stacks up pretty well, as you can see, compared to we'll have to figure out as A2Ls get adopted where it fits in the mix of things relative to first applied cost. Energy, it's a great refrigerant, as we get into the thermodynamic properties later on in the presentation, you'll see that it requires a lot less charge, and it's a very efficient refrigerant. And then, of course, maintenance costs are pretty good with this from a system perspective as well. If you think about convenience stores, really they fit in the mix between food retail and food service, depending upon what application is in that particular store. And when it comes to choosing a refrigerant system, it really is a balance between many different factors. First is energy. As you can see, you want less energy reduction. We've all heard of the rolling blackouts in California and across the country, and you want to make sure that the systems that you're choosing as an end user or the systems that you're offering as an OEM are going to be efficient for your customers. And R-290 is a high performance, highly efficient refrigerant. As you can see, compared to 404 in this chart on the bottom left, it yields better performance compared to 404 in many different conditions, around 20% better efficiency. Environmental impact. It's a natural refrigerant, non-toxic, with a GWP of 3 and 0 ozone depleting factor. So really great in that regard. And when it comes to applying this refrigerant in equipment, we think about reliability and long-term of the equipment. And so R-290 typically has higher high side pressures, which results in less work on the compressor and therefore equates to longer life in those different applications. It has less temperature variations, no glide, which is great. I know I've talked to several technicians over the year that just absolutely don't like glide, and so this refrigerant has 0 glide. And it's safe as long as those proper handling techniques that we'll discuss later on in the presentation are followed. And of course, when we look at the economics, lower running cost, reduced refrigerant charge is required. So refrigerant is just one factor in the total cost of ownership of a system, but the efficiency comes into play and the economics play out very well with this refrigerant. So right now I'm going to transition over to have Justin talk about some of the application expansion and what that means for different applications. Justin?
Yeah, thank you very much, Katrina. So what we're used to with R-290 propane at 150 grams really limits a small amount of applications available for use, such as domestic refrigerators, beverage dispensers, bottle coolers, small commercial reach-ins, and maybe smaller ice machines. And looking on the top chart, as you increase the available charge limit to be utilized in refrigeration systems, you increase the available capacity breadth of compression and available capacity of systems. So you can use R-290 in larger systems, larger commercial reach-ins and larger ice machines, and even getting into the self-contained walk-ins. Looking down at the R-290 application extensions, this enables us to be able to utilize larger capacity compressors, such as scroll compressors and other forms of compression that would typically not have been used with 150 grams just due to the charge limitation size. Also looking at these applications, ice machines, bigger reach-ins, bigger display cases, walk-in, self-contained only. It can't be used as remotes with the increase in charge limits. However, the 300 and 500 gram charge limits that is currently in proposal really enables the industry to be able to utilize R-290 in these systems. Currently, soft serve machines, there are no safety standards currently set for use of flammable or mildly flammable refrigerants currently. However, with the increase in charge limits, the available R-290 is now available for these system sizes. And the call to action here for the industry is to define a path forward for updating the safety standards in place to be adequate for soft serve machines. So how much is 300 and 500 grams of R-290? How much is it? So looking at some visualizations of some common household objects that you may recognize, there's over 9,000 grams of propane in a full propane tank that you would have out in your barbecue grill outside. That's a lot of propane. And then the smaller Coleman tank that you would use for, say, a camping trip has 454 grams of propane inside of it. So that is about the size of 500 grams. And then a common aerosol bottle, like a can of spray paint, 128 grams. And then the common household lighter, 99 grams of refrigerant. So the increase from 150 to 300 to 500 grams, just put it in visual perspective, this is what the size would look like. Also, the containers, the commercial grade, refrigerant grade R-290 comes in are very similar look to the propane tank and the Coleman tank. However, they are properly labeled. Also, it is important to note that you cannot use propane from these sources in commercial refrigeration equipment because the R-290 refrigerant grade is it's much higher purity. It is very low moisture, which is absolutely needed for a refrigeration system, and it has no odor. So propane that we're used to, that we know, we as consumers in our tank outside, has an odor added to it. That way we can smell it if it were to leak. R-290 does not have an odor to it because that is an additive that's not approved for commercial refrigeration systems. So there are many advantages to use of R-290, and Katrina did touch on a few of them. Mainly, there's probably 4 big items that are benefits or advantages of R-290. One, it's very low GWP, very low economic environmental impact. So GWP with 3. Number 2, it's highly efficient. It's really good performance. It's reliable, and it's safe when used properly in commercial refrigeration systems. And we'll get into the performance in later charts. Number 3, it is a natural refrigerant, so it's non-synthetic. And number 4, it is available and widely used in applications, and it's becoming a lot more available in other new applications with the charge limit increases that are ongoing. There are challenges with anything really good. There are challenges. A few of those just mainly go around the flammability characteristics and properties of the refrigerant itself. So we do need to continue training and putting forth training development for technicians to keep them certified and trained for use with R-290. It is not a drop-in refrigerant, and like many other refrigerants, it's not a drop-in systems, meaning the system does need to be designed and rated and approved for use with R-290. For example, you can't take out 134A or 404A and drop in R-290 into a system that's not rated and designed for it. That's very important. R-290 is compatible with all the oils that we use and compatible with copper and all the metals that are in refrigeration systems, which is an advantage. The charge limits do continue to be a challenge, but the increase to 300 and 500 grams in the United States will help with that. And then it is classified, obviously, as a A3 flammable refrigerant, which we'll get into the meaning of that. So there are safety mitigation strategies and safety mitigation approaches that need to be considered when used with R-290. So now I'll hand it back to Katrina for her to continue on the regulation and standards overview. Katrina?
Thanks, Justin. So what has to happen in order for those charge limits to increase? So the first step in the process is UL 2-89. This new revision for larger charge limits was published in October of 2021. That's the first step in the process. And so for self-contained, what it really boils down to is the LFL, meaning lower flammability limit. So for a closed case or a closed door case, the 300 grams is predicated on that 8 times lower flammability limit for that A3. And then the open doors of 500 grams is 13 times lower flammability limit. So the charge limits are really around making sure that it's going to be a safe, application. So this also included the A2Ls, which we talked about in the previous webinar for remote systems only. So, and then after that, ASHRAE 15 addendum for R-290 is awaiting publication currently, and this harmonizes the equipment standard with the safety standard from UL. And basically, you have to make sure all the ducks are in a row across all of these things to make sure that it's going to be widely adopted and easier to adopt, because if it's not, then it opens room for interpretation. So that next step, we're waiting a publication for that ASHRAE 15. And then after that, the EPA must allow the higher charge limits on the SNAP rules, which I'll talk about what SNAP is in the next chart. And then local building codes and state level building codes need to make sure that they're updated for that higher charge limit for R-290. So SNAP Rule 20 it has the authority for the EPA to be able to list refrigerants in different applications. And I'm not going to go through all of this. It's a little bit of an eye chart, but I think many of you might have seen this before. If we could just go down to the side where it says R-290, though, we can see that in medium and low temp standalone cases, as of today, R-290 you can use in those applications under that 150 gram charge. And then the newer refrigerants, the R-290 in an expanded, this will have to be updated for that expanded application. You can use it in ice and very low temp. However, if you look down the column where it says replacement, it is not a retrofit refrigerant, as Justin indicated, so therefore you cannot use R-290 in retrofit applications. In addition to all of those standards, when you're designing equipment, OEMs are designing equipment, they mildly flammable and flammable refrigerants must pass the Annex CC testing, and this is required for anything greater than 150 grams of flammable refrigerant for any appliances that have one circuit, at least with 150 grams. And it tests the concentration or the LFL of the refrigerant in the space to ensure that it's not going to have any issues. So it introduces, basically, you're in a room of 258 square foot. There will be sensors all around the equipment to measure the concentration of R-290 or flammable refrigerant. And then it'll introduce a leak simulation from the critical point. And then depending upon the leak rate, charge and leak rate, they're wanting to make sure that you're not going to have higher than acceptable lower flammability limits. So this is, again, Annex CC must be passed for any of these types of equipment with R-290 or A2Ls in the future. We talked about the refrigerants and we talked about the standards and codes, but what does that look like in terms of timing? So today, the second edition of UL was already passed previously, and then we anticipate the model codes are typically on that 3-year cycle. So by 2024, we believe that the A2Ls and A3s will be part of that model code, and then the building codes catch up. Their building codes are on like a few-year cycle, depending upon your location. So between 24 and 2026 is where we can see these refrigerants being widely adopted. Keep in mind, obviously, that OEMs and manufacturers of equipment need to make sure that they're thinking about that and building out their plans for larger charge in their system design processes. All right, with that, I'm going to turn it over to Justin to talk about some of the refrigerant properties and characteristics.
Thank you very much, Katrina. So moving on to the refrigerant properties chart. So looking at the chart at the top of the slide, you will see the 4 refrigerants that we know, R-404A, R-22, and R-134A, all compared to R-290 against these refrigerant properties. So starting out with GWP, as we said, R-290 has a very low GWP of 3. Moving on to the critical temperature, it's 206 degrees, which is higher than 404A, so nothing is a concern there in terms of the critical temperature operating in a system. LEL and UEL, Katrina did mention these are lower explosive limit and upper explosive limit. And what these mean in a flammable refrigerant, these are the percentages at which the volume of gas in a space relative to oxygen that is acceptable for the conditions are acceptable for combustion, meaning the LEL is a lower limit. So, and UEL is the upper limit. So if the percentage volume of R-290 relative to oxygen in a space is between those limits, then the conditions are right for combustion. And meaning that if there's an open flame or ignition source, the gas will ignite. So those are important to know, important to be aware of that. They're very difficult to measure. There is no good field way to measure these in the field. Therefore, a leak detection sensor or a leak sensor is needed when working on that, which we'll get into later in the presentation. But again, anything lower than the lower explosive limit, there is too much oxygen. It's too lean. The gas is too lean, so it will not ignite properly. And if the gas is above that 9.5% relative to oxygen, it's too rich. I mean, there's not enough oxygen to ignite. The ignition temperature just means when that gas will spontaneously ignite without a flame source, so 878 degrees Fahrenheit, very hot. And then getting into really the capacity, the efficiency, and the system charge. These are the beneficial properties of R-290. So the medium temp theoretical efficiency, this is just by looking at the properties itself, 112%, that compared to 404A. So it's meaning it's about 12% more efficient compared to 404A in a medium temp condition, which we'll see later in the chart on some field studies we did. Capacity is lower compared to 12% lower compared to 404A. However, it is higher compared to 134A. So that's important when designing a system with R-290 that's already designed with 134A or 404A. And Katrina mentioned this earlier, but 39% of the theoretical system charge, 39% of R-290 compared to 100% of R-404A, meaning a system that is traditionally would use 404A would use 39%, theoretically 39% of that volume of R-290, all else equal, to achieve the same cooling capacity. So to put that in terms of numbers, if you think 300 grams of R-290 theoretically, based on properties, would equate to about 750 grams of R-404A, which is about 1.7 pounds of 404A. So just looking at properties, theoretically, if a system is charged with 404A today, 1.7 pounds, it could theoretically achieve the same performance with 300 grams of R-290. Of course, there are many other variables that go into that the OEMs are well aware of, and there's a lot of things that go into the system design. But theoretically speaking, that's accurate. Moving down to the safety group chart. So what does it mean if we're a A3 or A1? So A1 means there's no toxicity and there's no flame propagation, meaning it's not flammable. So that's A1 is like 404A, 134A, R-22, 47, those refrigerants. Moving up the flammability characteristics, we get into A2s, A2Ls, and A3s. A3 is highly flammable, meaning that it will burn. Once it's ignited, it will continue to burn. A2Ls, for example, will only burn or ignite with an open flame source, open ignition source. Once you remove that source, then the gas will extinguish. So that's the definition, really, how to think about an A3, an A2L, or an A1. The B group is high toxicity. So really the only known refrigerant with an R number that's commonly used as ammonia. That's a toxic refrigerant. So that's a B1 refrigerant, for example. I did mention this earlier, but I do want to mention this, that R-290 does not have an odor to it. So it doesn't smell like propane as we as consumers know what propane smells like. So that's really important to know if you're a service technician working in the field with R-290, that you won't be able to smell it. And so you have to use the proper tools and the proper equipment to monitor if there's propane in that area before working on the equipment. R-290 is also heavier, more dense than the molecules in air, so it does have a tendency to want to sink to the bottom of whatever closed space it's in. So looking at the performance of R-290, so this is expanding upon the efficiency and the performance benefits of R-290. Emerson did a study with one single displacement compressor, a scroll compressor, and we looked at the energy efficiency ratio, which is simply just the capacity divided by the power input required. And we looked at 3 different refrigerants. We looked at 404A in yellow, we looked at 448A in blue, and R-290 in green. And we looked at 3 different conditions, which are difficult to read on this chart, but one is -10 degree evaporating, the other is +10 degree evaporating, and then +30 degree evaporating. So a low temp, a medium temp, and an extended medium temp condition. And this is all done at 120 degree F condensing, 40 F degree return gas. And we looked at the energy efficiency ratio. We saw about 12% increase in efficiency compared to 404A on a medium temp condition, which aligns well with the theoretical system efficiency that we would see. Again, another look at the performance characteristics on the chart on the right. So GWP, flammability, you see the compressor capacity midpoint condition is less than 404A at adequate conditions. However, it is not as less as 134A, so it's greater than 134A if you think about that. Efficiency, there's a 12% number, and then no glide, which is another beneficial characteristic of R-290. So now getting into an actual field study with an OEM partner, Lear. Lear compared R-290 versus R-404A in an ICE merchandiser application, and did both side-by-side comparisons in a real-world field environment, in a hot climate, and as well as a colder climate. So we did over a whole year of data analysis, and they graphed that relative coefficient of performance of R-290 compared to 404A. If you look on the chart, the blue line is R-290, and the yellow line is R-404A at varying ambient conditions, ranging from 60 degree ambient up to 120 degree ambient. And they set the coefficient of performance, relative coefficient of performance, on 1 at 60 degree ambient, and you can see how it trended throughout the time. This is based on real field test data. On average, a 20% improvement of the coefficient of performance with R-290 versus 404A, along with some other beneficial characteristics of the refrigerant. So Lear's, to summarize Lear's input on R-290, it's environmentally friendly. Lear has also found that the high side operating pressures and temperatures combined with its higher thermal conductivity allow it to deliver improved benefits across a wider range of ambient conditions compared to legacy 404A systems. So now we'll start to get into some of the safety considerations, service considerations, and best practices when utilizing R-290. Before I start on this, I would like to note that this does not intend to be a full comprehensive service manual or service training. There are plenty of resources out there available online for certification of use with R-290, for proper training and education with use in R-290. This is meant to be just a guide and just things, provide resources and references people in the industry to look up. So speaking of that, there is a good specialized training from Refrigeration Service Engineer Society, rses.org. They do offer a HVAC training class where attendees can go and actually take a service or take a seminar based on service and have to learn a manual and get a certification to work with R-290. So that's a very good resource and very good document to have for technicians that want to work with R-290. R-290 it's a safe refrigerant when utilized properly and when well aware of what the refrigerant is. It's flammable, so keep away any open flames, any ignition sources, that sort of thing. And the key is, before working on any refrigeration system that has R-290, they are properly labeled. The manufacturer will label the system. The compressors are labeled properly. You can identify it. You can also find red sleeves on the tubes that connect to the compressor that are a requirement to be on R-290 systems. It's heat shrunk on to represent that those connections have a flammable refrigerant inside of them. The first thing any technician should do before servicing is put on a flammable refrigerant leak detector and put that into the area they're working, and make sure that's always on and always there when they're servicing the equipment. That will alert you if there is a R-290 in that area, any R-290 in that area. And it's important. I think the three things that the technician should always remember is monitor, ventilate, and eliminate. So monitor the situation, monitor the environment, and if there is R-290 in there, you need to ventilate that. So you need to get it out of the area, and then eliminate any possible open flame sources, and make sure that's always done. Also, it does require to have safety placards put in place for no smoking, that there's no open flames, that there is a flammable refrigerant, that the technician is working in that area. Something also with R-290, it is a natural refrigerant with no GWP or very low GWP. Therefore, it can be properly vented to the atmosphere as long as the proper EPA regulations are followed. Those are available online. But one of those is that it should be vented outside, whether the system would be outside, outdoors, or there's lines that run outside to be vented. R-290 can also be recovered, just like any other refrigerant can. Recovered and reused as well, as long as it has the proper labeled containers and the proper equipment to do so. Some brazing, obviously with a flammable refrigerant, brazing is important to make sure you follow all the right protocols for that. You need to be working in a well-ventilated area to keep ventilation, to keep that gas ventilated. Obviously eliminate all ignition sources. Key here is when brazing, you want to be purging the system with dry nitrogen to displace any trapped propane in the system. So that doesn't require very much pressure, 3 to 5 psi of dry nitrogen to continue to purge that system. That needs to be running the whole time you're brazing. Prefer to use tube cutters over a torch, just to eliminate another potential flame source, and then also evacuate the system to 500 microns. So follow the same charging procedures and handling procedures with R-290 as you would with any HFC refrigerant such as 404A or 134A. So R-290 handling, so this is more in regards to the container or the tank itself of R-290. You would handle it the same way you would any other refrigerant, except with the extra precautions that you do have to make sure you have the proper labels on the container. Never refill disposable cylinders. Never fill a recovery cylinder with a non-approved refrigerant. Never apply an open flame to a cylinder. So all the same kind of precautions you would with HFC refrigerants, you apply to R-290, except you would use the appropriate labels and appropriate cylinder for that refrigerant. Also, keep valve caps on the tank at all times, unless you're going to be accessing those and actually utilizing that container. It's just important to be aware that this is a flammable refrigerant. So with that, I'll hand it back to Katrina to wrap us up.
Thanks, Justin. So as OEMs start to design, Emerson larger charge R-290 systems, Emerson offers a complete range of compression, condensing unit controls, drives, as well as valves for different systems, and we're there to help our customers through that process of designing and developing their systems. We also have a great lab in Sydney, Ohio, that is a A3 and A2L lab, and of course our application team as well is available to help with any designs and questions that you might have from that perspective. And then, of course, Emerson has a E360 resource for R290 out on our website. There's lots of great on-demand content, whether that be webinars, articles, videos, training as well, brochures and blogs, all available out there to the public to be able to get further information on this particular refrigerant. And of course, again, this is wrapping up our series this summer. If you missed any of these other refrigeration webinars, please go out to our E360 website, and we have all of our previous ones posted. So there's a deep dive on regulations, the role of emerging CO2s, just as a high level, and then we get deeper into A2Ls and CO2 on other webinars. This kind of wraps that all up. So with that, I will open it up to questions.
Okay, Katrina, we did get a lot of good questions that came in. We'll get to as many of them as we can. The first one actually was for Justin. It came in during that last section when you're talking about service. The question is, what tools and equipment are required to work on flammable refrigerant systems?
Yeah, that's a great question, Brian. Thanks for asking that. So number one is a combustible gas monitor, so the leak sensor, as I was saying. Appropriate PPE is required, such as safety goggles, gloves. The safety placards, which indicates the flammable gases may be present. That's important. You always want to have a Class B fire extinguisher nearby and ready in the case of an emergency. A ventilating fan is a good tool to have. Recovery equipment, vacuum pump, tank, manifold gauge set, which I didn't mention in that, but you can use, it is suggested you can use the same a manifold gauge set that you would use for say 134A, very similar. But if you can get one with R290 pressures, that's ideal. But you want to have that rated for flammable refrigerants. Dry nitrogen to purge the system lines. You want to have a pinch off or cutting or tube cutter tool. You want to have a crimper and crimper valves. You want to have the appropriate replacement refrigerant for the system being serviced. And then at the end, you want to have liquid soap available to check for any leaks.
Okay, Justin, thanks. Katrina, with the higher charge limits, the question is, can I retrofit an existing refrigeration unit to be compatible with the R290, to retrofit it with propane?
Any existing refrigerant cannot be retrofitted to R290. R290 has to be native to that application for it to be the SNAP approval to apply. So okay. Existing, you cannot change out, no.
Okay, good. Justin, a question came in. How do I know if a refrigeration system is approved for use with flammable refrigerants?
Yeah, so you want to check the labels within that equipment. So the equipment will be properly labeled. It will have, usually on the inside of the equipment or on the outside of the equipment, there will be a proper label for that. Also, the compressor will be labeled. It is an ASHRAE, I believe it's an ASHRAE requirement to have R290 labels on the compressor itself, multiple locations, so you can see that. Also, if you're using, say, an Emerson system, or excuse me, an Emerson compressor condensing unit, you can also go onto our online product information webpage and type in the model number, or scan it on your phone if you have Copeland Mobile, for example, and it'll bring up what refrigerant that is and all the details of that.
Okay, we got a couple questions about the size of equipment. We were talking about going to larger, and a couple questions were, and this is for both Katrina and Justin. Is Emerson going to be ready with larger propane compressors and condensing units? And how large are you thinking about going? I think we had a slide that talked about the size of systems that we were looking at getting up into.
Yeah, Katrina,
Sure.
I can take that.
Go ahead.
Yeah. So yes, the answer to that is yes. Emerson does have a full portfolio available for R-290 compressors, condensing units, all the way up to our scroll size. So if you talk horsepower, up to 1.5, 2 horsepower size in the United States. Now, our friends over in Europe have been using R-290 longer and bigger applications, and so we have a full portfolio of much larger compressors available in Europe as well. But in the United States, we do have the lineup available for scrolls, hermetic recip compression, condensing units, horizontal scrolls and condensing units to utilize to go into systems to utilize the higher charge limits.
Yeah, and today the charge limits are at 150 grams. However, there is a proposal to go 300 grams for open door. I'm sorry, 300 grams in open appliances without doors, and then 500 grams for open doors and 300 grams for closed doors. So you cannot do that today, but once those approvals get through, then you would be able to use those larger charge limits.
Okay, good. Again, any questions that came in that we didn't get a chance to answer today, we will respond to you in writing. I think we're going to do one more question. This one's for Katrina. So how can I learn more about the R-290 and flammable refrigerants?
Yeah, so there's lots of great resources out there for R-290 learning and knowledge. So first is a document or the resource that Justin mentioned earlier, the RSES guide. Refrigerant Service Engineers Society offers that digital certification for HVAC refrigeration technicians working on flammable refrigerants. In order to pass, the technician must study the hydrocarbon refrigerants, a guide that helps service technicians through that. In addition, I talked about Emerson's resources. We also offer training classes either in person or through our website's self-pace. And then mainstream engineering, HVACR personnel can go through FO certification through mainstream engineering at the EPAtest.com portal. This is a certification that accompanies the guides to cover techniques and regulations and handling safely refrigerants. And then, of course, all of the major manufacturers, OEMs, offer their particular training from an equipment source. So really, I always like to take a 360 view when we talk about learning in general. So trying to learn from multiple sources is really the key.
Good. Thank you, Katrina. I'm going to turn this back over to Kate now.
Great. Thank you, Brian, and thank you, Justin and Katrina, for presenting out for us today. So that's all the time we have for questions today. Thank you again for your participation. Like Brian mentioned, any questions that we were unable to answer during our time today will be sent out directly to the asking individual in the coming days via email, so keep an eye out for that. And as a reminder, a few days after this live event, you can access this presentation on demand or view previous E360 webinars at e360hub.emerson.com/webinars. And you'll also receive an email in the next few days with a link to the recorded event. If you want to subscribe to our monthly E360 newsletter and access all of our E360 content, visit e360hub.emerson.com. If you'd like to explore today's webinar topic further, please visit the links found within the resources tab shown on the screen. Please note a survey will appear after the webinar has concluded. We would appreciate your response and hearing your feedback. On behalf of Emerson, thank you for attending today's E360 webinar. Information and registration will be available soon for our next upcoming webinar. We hope you can join us again. Thank you.